Hello everyone, my name is Chetan Sadamate and I am going to discuss about earthquake surface waves. Earthquakes are powerful natural phenomena that release vast amount of energy in the form of seismic waves. These waves travel through the Earth's interior and across its surface, causing the ground to shake and sometimes resulting in shocking damage. While body waves which travel through the Earth's interior are essential for understanding the Earth's structure. Surface waves plays a crucial role in understanding the earthquake impact on the Earth's surface and are primary focus for seismologists. What are the earthquake surface waves? Earthquake surface waves are the types of seismic waves that travels along the Earth's surface unlike body waves, which travels through the Earth's interior. Surface waves only propagate through the outer layers of the Earth. They are generated when an earthquake occurs and travels outwards from the epicenter, causing ground to shake and deform in complex pattern. Longer wavelengths. Surface waves have longer wavelength than the body waves, which means they can travel farther and causes more damage. Surface waves are especially damaging to buildings and infrastructure, causing them to sway and potential collapse. Then slower speed surface waves travel slower than the body waves. This difference in the speed is what allows seismologists to differentiate between the different types of seismic waves and to locate the epicenter of the earthquake. Surface waves versus body waves. Surface waves are the primary cause of destructive and damage associated with earthquake. They are responsible for shaking and rolling motions that are felt during a large earthquake. The energy of these waves decreases with distance from the earthquake's epicenter, making them less impactful in areas further from the source. Ground deformations. Surface wave causes the ground to deform in complex pattern, resulting in the up and down and side to side motions observed during earthquake. The specific pattern of deformation depends on the type of surface waves. So, now we discuss about types of surface waves. One of them is Rayleigh and second one is love waves. So, Rayleigh waves are named after Lord Rayleigh, who first mathematically predicted their existence. They are combination of vertical and horizontal motion, causing the ground to roll like a wave. They are the slowest of the surface waves, but they are most destructive because they can travel long distance and causes significant ground displacement. Then second type, that is love waves. Love waves named after August Edward Hogg Love, a British mathematician, are purely horizontal waves that cause the ground to shear. They are faster than Rayleigh waves and their amplitude is typically smaller. They are less destructive than Rayleigh waves, but they can still significant damage to buildings and infrastructure. Then characteristics of surface waves. Surface waves are characterized by the wavelength, amplitude and frequency. These characteristics plays crucial role in understanding the propagation and impacts of surface waves. So let's discuss about that characteristics. First one is wavelength, the distance between the two successive crests or trough of a wave. Then amplitude, the maximum displacement of a particle from its equilibrium position. Frequency, the number of waves that pass a given point per unit time. Then propagation of surface waves. Surface waves propagate outwards from the epicenter of an earthquake in all directions. As they travel, they lose energy due to friction and other factors, which causes their amplitude to decrease with distance. The rate at which the amplitude decreases depends on the characteristics of the surface waves and the underlying geology. So epicenter. Surface waves originate at epicenter of an earthquake where the initial rupture occurs. Then propagation, the waves travels outward from the epicenter, spreading across the earth's surface in all directions. Then weakening. As the wave travels, their amplitude gradually decreases due to energy dissipation. Measurement and detection of surface waves. Seismologists use specialized instruments called seismometers to measure and record surface waves. These instruments are sensitive to ground motion and can detect even the smallest tremors. They are usually installed at seismic stations around the world, which forms a global network for monitoring earthquake and other seismic events. The seismometers. These instruments are designed to detect and record ground motions caused by seismic waves. They consist of a mass suspended on a spring that moves relative to a fixed frame. When the ground shakes, the relative motion is measured and converted into electrical signal, which is then recorded. Seismic stations. Seismic stations are locations where seismometers are installed to monitor seismic activity. These stations are typically located in remote areas with minimal human activity to minimize noise and interference. The data from this station is transmitted to center data processing centers for analysis. Data analysis. The data recorded by seismometer is analyzed to extract information about the characteristics of seismic waves, including their arrival time, amplitude, and frequencies. This information is used to locate the epicenter of an earthquake and to estimate its magnitude. Importance of surface wave in seismology. Surface waves are crucial to understanding the earthquakes and Earth's interior. By studying the propagation and characteristics of surface waves, seismologists can learn about the Earth's structure, composition, and properties. Earth structure. The surface waves are sensitive to the physical properties of Earth crust and upper mantle. By analyzing the way surface waves propagates and changes as they travel through the different layers, seismologists can create detailed models of the Earth interior. Earthquake source. Surface waves provide information about the location and characteristics of the earthquake source. By analyzing the arrival times and amplitude of surface waves from the different seismic stations, seismologists can accurately locate the epicenter of an earthquake and estimate its magnitude. Earth's properties. The behavior of surface waves can be used to study the elastic properties of Earth's crust and upper mantle. This information is crucial to understanding how these layers deform under the stress and how they respond to seismic events. Conclusion and future research direction. Surface waves are a valuable tool for understanding earthquakes and earth structures. As seismologists continues to advance, we can expect to see even more applications for surface wave analysis. Future research will be focused on improving our understanding the propagation and characteristics of surface waves, as well as developing a new technique for using surface wave data to address real world problems. Thank you.